appar och mobilappar för att vara specifik. Något av den heliga graal inom detta område är förmågan att med en gemensam kodbas kunna rikta sig mot olika typer av plattformar, operativsystem och device. Och vi ska nu få höra om ett nytt lovande ramverk för detta som är framtaget av ingen mindre än IDE-giganten och tillika skaparen av Kotlin, nämligen JetBrains. Nästa talare som håller på att göra sig redo här skulle jag beskriva som en hängiven och mycket erfaren frontend-arkitekt som ständigt är på jakt efter det nya svarta. Och han kommer switcha språk, är jag rätt säker på. Så jag säger helt enkelt, please join me in a big round of applause for Stephen White.
Hi everyone, can you hear me? You can hear me, right, cool. Hello, welcome, my name's Stephen White. Fantastic introduction by Andreas. I work with front-end stuff and mobile stuff, amongst other things. Also do quite a lot of back-end stuff as well, bizarrely enough. But today, I'm going to talk about Compose Multiplatform, which is, well, kind of new from Kotlin, basically, but it's built on top of Jetpack Compose. So if you've done any Android development, you might have heard about this. So what are we going to do? First of all, what is Compose Multiplatform? And I'll call it CMP because it's a bit of a mouthful. So I'll say CMP in future, and I mean Compose Multiplatform. Getting started, how do you get started? Then there'll be a bit of a demo. I was going to do some live coding, but it's going to be some live branch switching, I think, just to keep time down, as it were. Ongoing development, what's going on in the community at the moment, really, with CMP. And then finally, some final thoughts. Okay, so what is Compose Multiplatform? Well, it's already in your hand. So if you've downloaded the app and you've been asking questions, you've been using Compose Multiplatform. So let's have a deeper look at it. So first of all, it's a multi-platform UI framework built by JetBrains, and it's built on top of Jetpack Compose. So basically, it uses all of the APIs that you get for Jetpack, but it kind of gives you the ability to be able to create multi-platform apps. And what I mean by multi-platform apps is that you're able to deploy both on iOS, Android, desktop, and maybe sometime in the future web as well. So Jetpack Compose APIs. So if you're used to doing Android development, you can jump straight in really with this. So traditionally, if you take Android and iOS, we have two separate devices, two separate operating systems, two separate languages, Kotlin, Swift. And you can see that, you know, the UI part, the domain part, and the infrastructure part of your app are totally separate. So you have two separate teams working on this. And both of those teams are very happy that it's like this, I think. But with Kotlin Compose, which came out a couple of years back, you had the ability to be able to share both domain and infrastructure logic within your apps. But the UI side of things was still very separate. So, you know, the Swift guys would be doing their Swift UI stuff, and then the Jetpack people would be doing their Compose stuff. But now we're able to share the UI layer as well. So now you're able to do everything with one language and one framework, which is both good and bad, but I think it's pretty good. The other thing is that it's not just for Android and iOS. You can also do desktop and web. So you can have one code base which you can bring to all of these different platforms, which is very, very cool. You know, if you want to bring down costs and you want to consolidate your team just in one language, for example. But you also have the ability to be able to mix and match with iOS. So you can still write Swift alongside Jetpack Compose stuff. So you can switch, you know, between these two. And this is kind of handy, you know, if you've got some very complicated Swift UI stuff, you know, you can still reuse that in a Jetpack Compose situation. Okay, so we have iOS, Android desktop, and also an experimental web version, which is there at the moment, but it's very much experimental, and that builds on WebAssembly. Okay, and if you're using JetBrains, you're probably already using the desktop version of Jetpack of CMP or Compose Multiplatform, in the sense that of the JetBrains toolbox that you have up in your header of your Mac, for example. Okay, from an iOS perspective, it's not stable. Okay, you might already you might have installed the app on your telephone, but it's still not quite stable, and there's still quite a lot of API changes going on. So at the moment, we're still in alpha, but hopefully sometime at the end of 2024, we'll be in production. But they're hoping to kind of move things into beta during 2024. And hopefully I can go into some of these kind of beta-ish or even alpha-ish kind of aspects that we have at the moment. Again, from an interoperability perspective, you can basically mix and match SwiftUI with Jetpack Compose and vice versa. And this is very, very flexible. So it's very flexible. So you don't have to just jump in and refactor everything to CMP. You can do it gradually. So getting started, what do you do? Well, first of all, you need an IDE. You could use Vim or Emacs or something, or you could use Android Studio, or even the new fancy Fleet, which has recently come out and has very good support for CMP. And obviously, because it is multi-platform, you will need Xcode. So this is a bit different to, say, React Native, where you don't actually need Xcode to be able to build and deploy your app. But with CMP, you do need Xcode. And this is because you're actually building binaries. You're not just building a JavaScript bundle, as it were. You're actually building an app. Okay, and then obviously you need an emulator and you need a simulator. So this is the kind of toolkit that you need to get started with. But there's no way of creating a new project, say, in Android Studio. You need to go to this wizard that JetBrains have nicely created for us. And you basically tick off some boxes. I want Android, iOS, desktop, web, and also the server part. And the server part's kind of interesting because it means that you're able to use a KTOR server or whatever HTTP server you would like to use for your app. So you can keep everything in one language, Kotlin, and everything should be pretty straightforward, from jumping between layers of your application. So you fill in the boxes, click download, you get a tar file, which you can unzip, and then you're ready to go. So we'll have a look at this in a minute. But before you get going, you'll probably run into all kinds of issues relating to what Java version you've got, what Xcode version you've got, etc. But JetBrains are very kind in providing something called KDoctor. So it just basically gives you a sanity check of your system to make sure that you've got the right Java, the right operating system, Android Studio, Xcode, and also Cocoa Pods for doing Xcode, for doing iOS. Okay, so now then, we're going to do a demo. So I'm going to switch over to my fantastic code branching stuff. I'll just drink some of this. And I thought that what we'd do is that we'd build a star bar. So in the app, you can see a list of all the speakers, but maybe sometimes it's nice to be able to star them and say what you thought of them. If you like that, personally, I can't stand doing starring on anything, but you can do that if you like. So let's quickly pop over to Android Studio, and so I've downloaded that star bar tar file. I've unzipped it, and now I want to run it. So here I am in Android Studio with the initial project, and I can just run this, and you can see the project actually started up pretty quickly. That was quite nice. I thought it was quite smooth, and this is what you get out of the box. But it might look pretty basic and pretty boring. It's just a button, and you've just got an animation here. But just having animations out of the box is actually really, really, really nice. And it's something that you have to kind of fight with a bit in React Native, depending on what library or whatever you're using, basically. Okay. One of the things you can see here in the app file is that we've got a material theme. So you get theming out of the box. And this comes directly from Jetpack Compose. A material theme is something that you would definitely use in Android, but in iOS, it's kind of debatable, really. It depends on your design system. So let me just let me do this. So what I've done earlier is that I've created a new theme, which just has a bunch of different colors. And again, it's a material theme composable. And there's a bunch of shapes in here. And also you can do typography and you can do a whole bunch of other things that are related to the material theme. But it's composable. So it's kind of like React in the sense that it's a provider. It's providing these properties further down in your composable hierarchy. So you can see that we're wrapping everything within this theme. So now if I run this, hopefully we should get some pretty nasty colors. Yep, we do. So I can click on this and you can see we've got a pink background. And also, I don't know if you can see it, the button's kind of rounded. So we've got those shapes. So you can use a material theme. And this is actually very nice because theming can be a bit complicated if you start off with React Native, unless you're using something like Tamagui or you're using a particular theme framework. But you get Jetpack Compose or Android theming directly out of the box. Okay, so let's create those stars. I'm going to jump ahead here. So I'm just going to go to branch 4. And let me run this in Rick. Okay, let me shut that down. Yeah, right, okay, great. Rick's over here. And then I'll run this in the iOS simulator. One thing to say here is that within Android Studio, because of the Gradle magic that's going on in the background with that, with the boilerplate kind of project that you get all these targets. So there's an iOS target here, and this presupposes that you have a simulator installed. So we can click on iOS app. I can click here, and hopefully we should see it appearing over here as well. Yeah, right, that's great. So before I show you the app, let's just have a quick look at some of the code. So we can start off with the app file. We've got our star bar composable, and then I can just quickly go into that. And we've got a whole bunch of stuff in here, but I try and be concise. The first thing is that I wanted to show you the view model. So the important thing with this star bar is that there's a view model which is holding state, and also there's networking. So we've got a HTTP client or the KTOR client in here as well, and all of that is encapsulated within our view model, as we can see down here. So, like within Jetpack Compose, you specify your state. And then you have a class, which is your view model, and you have, well, basically functions that do side effects that call stuff on the network, and also manipulate the state or mutate the state. So it follows this kind of unidirectional pattern that you get in React, as it were. Okay, so let's go over to our stars. So I can click some stars here, and this is really great. But you can see that the stars aren't being updated over here. So one of the things that I've implemented is pull to refresh. Ta-da. Okay, so we've got pull to refresh going on here. I can come over to Android and pull to refresh here. Now, if you look closely, pull to refresh looks great on Android, but on iOS, it looks like Android. And if you just spent 17,000 crowns on your fancy new iOS or iPhone, you don't want Android design tokens showing up on your fancy new iOS telephone. Well, I don't anyway. So there's a bit of work to be done from a design system perspective. You know, okay, you get material theming out of the box, but actually, most of the time, I don't want this on my iOS telephone. But in your organization, you know, you would have created your fancy design system in Figma and stuff, so hopefully you can get around this kind of stuff. You know, this is what you get out of the box. Okay, so we've got our star bar. Now, the thing is that I want to see that also within the app. So I'll open up the app here. Open up Cadec. And I'll go to the talks, as we can see here. And you can see that, you know, the scrolling's quite nice. We've got, we can sort of go into a talk, for example. And if you notice here, there's a blurred background. This might seem pretty subtle and like pretty inconsequential, but again, you know, that's just one line of code to be able to get that blurred background. And in React Native, it takes a bit more than one line of code to do it. And in some cases, you might not be able to do it at all. So, you know, there's quite a lot underlying, you know, that you get from the Jetpack Compose APIs that you get in CMP, which is really nice. And the other thing is that if we want to ask a question, so when I click on that, you get a bottom sheet turning up. Now, you know, all of these things just kind of blend into your general experience of using your telephone. But a bottom sheet is like a very crucial kind of design aspect to any mobile app. And actually, you know, the implementation of bottom sheets in React Native is something that's taken some time to perfect. So it was actually quite nice to get this straight out of the box. So let's ask myself a question. Hi, Stephen. Oops. Is this a RN? Oh my God, I'm in Swedish mode. No, sorry. Is this a RN? No. Okay, right. It's in English, isn't it? Is this a React Native Slayer? Okay. The other thing, well, I've got to point this out. I mean, it's a bit tacky, you know. I've got like gradients going on in text that you can see here, and I love tacky. I love this kind of stuff. But the important thing is that it's really powerful. You know, you can chuck a gradient directly on what's known as a modifier in your composable, and it's just really easy to do. So you could do some really bad design really easily. In React Native, you have to work quite hard to be able to do this kind of craziness. Okay, I'm going to submit that. Maybe it'll show up later in the questions. Okay, so, oh yeah, the stars. I was going to show you the stars. Right. Let's have a look. Let's do this. Okay, hopefully this will show up. So if you've got your apps open, hopefully the stars would have shown up now. And we can see that here. So I can give some stars here. Obviously Magnus is worth 5, but someone's been playing around with that. But you can see here that I'm updating the stars, and also the average stars are updating as well. So that means that there's a WebSocket connection here as well. So doing networking is super duper easy, you know, very usable. Let me just, let's see if I can do this. I'll go to home. Okay, I've got the Cadec app here in the simulator, and hopefully you can see it here. Yeah, bingo. Right, okay. Yeah, okay, so you can begin to see some of the star values updating. Okay, but as I said earlier, I really don't like stars, so I'm going to turn that off. Right, last chance, it's going, it's gone. Right, okay, hopefully it's gone now. Great, okay, so let's go back to the presentation because I've got 1 minute and 20 seconds, okay. So we went over a bunch of things, look and feel, Android, patterns, bottom sheet, navigation, resources. I didn't talk about fonts, which is interesting. You probably might have noticed that they're not standard fonts that we've got. They're specific kind of Calista fonts. Okay, and obviously it's an app on the App Store. So you can release this. You can create archives and release it. So ongoing development. Let's do this very quickly. There's a bunch of holes within what you get out of the box. And specifically, there are things like view models and navigation. So in the app, I'm using something called Voyager. And navigation is something that you would expect to get because everyone wants tabs, everyone wants stack navigation. Persistence, you do actually get Android's data store out of the box, but if you want something a bit more robust, you can use SQLite, Realm, which is a Mongo-based database that you can have on your device, or KStore. Okay, obviously there's a really good website, and also there's a Slack channel as well, which you can sign up to. As you can see there, Multiplatform, which is great. Okay, final thoughts. Early days, you can target Android first. That is production ready. And then you can kind of transition into iOS at some stage. And one of the main things for me when I think about the whole CMP is this business of complexity. If you've got two teams, first of all, you've got accidental complexity. So you've got multi-platforms. You've got two different code bases. It just creates complexity, basically. And then also you've got essential complexity, which you could say is like the language. So if you can mitigate all of this, you can really begin to take down your technical debt, which does build up over time. And also if you have one language, it gets rid of any kind of mental dissonance. So you can have one language per app, but also you can have one language per layer of your application. So you can use Kotlin both in your back end and also in your front end. So it kind of really cuts down on this kind of dissonance that you have jumping between layers or even between applications, which I think is really good. So you can use it in the clients and also in the back end. That's it. Thank you.
How does CMP differ from Flutter?
Oh dear. I'm not really a Flutter person, but one of the interesting things is that from an Android perspective, well, Flutter, first of all, uses something called Skier to be able to render everything on both Android and on iOS and on the other platforms that it supports. Now, the thing with Skier is the rendering mechanism that's also used in Chrome. So when you look at stuff in the Chrome browser, everything's rendered with this Skier. Okay, now the thing is that things like accessibility is actually quite difficult because you're rendering, it's like you're rendering a PDF, for example, in your Android device. But accessibility is attached to each different native component, like a button, a text box, a tab, whatever. You speak into the phone and you expect it to go from one tab to the next, for example. So doing things like accessibility is very, very difficult with Skier. And if you've used Flutter, that's been one of the main kind of gripes, essentially. Now, with CMP, you have native components in Android, but actually you have Skier in iOS. So you do have the same kind of issue on iOS, but on Android you have natural native components.
Ja. Närbesläktad fråga. Varför väljer detta istället för React Native?
Because I was doing this talk. And I wanted to learn it. I don't know. I mean, I'm really a React Native developer, so this was actually quite difficult for me to do. Every time when I was doing the app, I was just thinking, this would take me 5 seconds to do in React Native. Why am I doing this? But I just kind of, I wanted to push myself through it because I really like Kotlin as a language. I think it's a great language. There's some finesses in Kotlin which you don't get in TypeScript. The kind of the typing aspect in Kotlin is just superb when I compare it with TypeScript. And I think that's one of the things I really wanted to explore and see.
Mm. How does CMP handle things like Bluetooth, camera, and other problem areas in cross-platform development?
Yeah, it's all there. Because it uses the Jetpack Compose APIs, all the kind of access to native kind of devices like your camera or whatever are all there, or Bluetooth. So it's kind of out of the box. It's the same API that you would use for Jetpack Compose. Yeah.
Cool. Let's see. Have seen former React Native developers on forums saying the developer experience is nightmare. Your thoughts on that?
A nightmare for React Native or for?
No, I guess for CMP.
For CMP, yeah. I mean, the thing is, I mean, the React Native community is unbelievably spoiled. We've been going for 6-7 years or something now. So the tooling is just amazing. Especially from a hot reloading perspective, you type a piece of code and then immediately everything just pops up and changes. We don't have that here. But again, as I said earlier, you're actually building a binary. It's not a JavaScript bundle that's being displayed within a binary or within a native shell. You're actually, every time you do a code change, you have to rebuild the binary. So I guess as your app grows, the developer experience will begin to sink. And I think that's just a great excuse to get a bigger machine. So it's a great job that the M3 Max come.
Great. We have time for one more. How do you get an app through the App Store that can be changed after being deployed live on the end user devices? Isn't that a big no-no and security risk?
Yeah, it's a big. Well, you can't do that with this because it's a binary. So every time you want to re-release something, you have to go through the whole release mechanism in both the Play Store and also the App Store. Which in the App Store it's actually okay, but you'll notice that with I didn't manage to get out a an Android version of the app in time, because the Play Store have introduced like 3 testing stages before you can actually release anything, which is a complete nightmare actually. So that's why I've just given you an unsigned APK there. But yeah, I mean, like over-the-air deployments that you have in React Native, there's a lot of question mark. I mean, it's great, it's amazing. You can push things out directly. But I've been in projects where I've pushed stuff out to production which I shouldn't have pushed out, especially when, like the CEO's been in meetings with clients and all of a sudden they're looking at stuff that shouldn't be there. And then they phone you and say, what the hell is going on with this? You're just thinking, oops. So, it has its pros and cons. The other thing is the security aspect. You can intercept that bundle as it's being pushed out, and you can manipulate it or push out your own bundle. So there's pros and cons.
Yeah. Thanks.
Yep.
Yeah. And with that, a big applause.